In this video, we're learning about gravitational forces. So we'll cover what gravity is and how we can map gravitational fields. Let's start with what gravity is. You can think of gravity as a force of attraction between two objects, and the size of that force depends on two things: the mass of those two objects, and then also how far apart those objects are. And remember here that we use the term mass to describe the amount of matter in an object. So for objects that have a small mass like apples or even buildings, the gravitational force of attraction is so tiny, it's as though it doesn't even exist. And the same goes for huge objects like Jupiter that have a really large mass but are far away. The gravitational force of attraction is still tiny between this building on Earth and Jupiter, even though the planet is so huge because it's just too far away. However, for very large objects that are also close by, such as the Earth or the Moon, gravity is felt far more strongly and can have a big influence over nearby objects. We call this field of influence around an object its gravitational field, and the strength of this field is called the gravitational field strength, which we show with the letter G. For Earth, this is around 9.8 newtons per kilogram, sometimes rounded up to just 10, while for the Moon, it's just 1.6 because it's a lot smaller than Earth. The forces of gravity between the Earth and the Sun are also really strong, even though they're quite far away from each other. This is because the Sun is so enormous that its gravitational field strength is around 274 newtons per kilogram. Importantly though, gravitational forces are always attractive, and this means that masses always pull towards each other, but never push away from each other. This is different from some other forces, like magnetic forces, which can either attract or repel. Next, let's explore how we can map gravitational fields. Gravitational fields are invisible, and they extend through space around any object that has mass. This means that gravity can act on objects without the objects actually touching each other. What's really useful is that we can map these gravitational fields by observing their effect on a test object. We use the word test object in this context to basically describe any object that we can observe being affected by gravity, like a ball or any other mass. For example, if we place a ball at different positions around a massive object like Earth, we can then observe how the gravitational force affects it at each location. The ball will always be pulled towards the center of the Earth, and the strength of this pull tells us about the field strength at that position. By testing the ball at many different positions, we can create a map showing how the gravitational field extends through space. This map would show that the field is strongest close to Earth, but gets weaker as we move further away. Importantly though, it extends infinitely through space, just becoming incredibly weak at large distances. This mapping technique helps scientists understand not just Earth's gravity, but the gravitational fields around other planets, stars, and even galaxies.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.